In previous video we talked about the Slater's rule. Now we discuss why the size of cation is less than the size of its parent atom. Okay. So anyone give a reason? Again, the second question is the size of an ion is greater than the size of its parent atom. Okay, anyone give the reason? So let's take a decision. First saying that the size of I am saying C plus is greater than the sign of less than the sign of origin. For example, this is our material. Say it is a proton as well as neutron, electron in its surface, and neutron is in a nucleus. Now, for example, a cation means it has large amount of positive charge. For example, you have in a bowl, you have in a pot, for example, black color marbles in 10 and white color marbles in also 10, but in somehow your white color marbles is you share the white color marbles in your friend. Say, take my friend, please take care of my one white color marble. It is electron, so you share electron. Now you have a black color or blue color marble in large amount, it has 10 and the white color is 9, and your friend has 10, 11 white color marble. So now you have a large amount of positive charge. It means that you squeeze your size. Okay, and for example, this is your parent atom and this is now your new atom. So this is your parent atom which has blue marble is 10 and white marble is 9, and your parent atom has 10 and 10. Okay, so we clearly seen that the size of it is large because it has extra marble in with respect to your new situation. So in this case you are positively charged because you have the black color marble with the positive and this is a negative charge more than it has a more in the neutral, like in both same. So in this case the size of it is less than the size of parent atom because it has an extra amount of the electrons. So that's why, for example, let's take another case. For example, is the proton. So this is the electron and the side of the atom nucleus. So if electron is loose, so the size and again squeeze. Okay, so that's why the size of it is less than the size of its parent atom because it has same attraction force with nucleus and this last part. So that's why we simply saying that the size of cation is the size of less than the parent atom because one electron is lost. And similarly for anion, in this case you have 11 marbles. You have 11 marbles in white color and protons are 10, so that's why you have a negative large amount, that's why you have a negative charge. And your parent atom has same 10 blue and 10 white, and that's why you have attraction, you have more electron in the last in the nucleus. That's why around your orbital. So that's why you have a great expansion as with respect to your parent atom, and the amount and the size of yours great increase with respect to your parent atom. That's why the size of your parent atom is great less than the intense of your current atom which has anions. Okay, so I explained both part why because of electron loose and here the electron gain and electron loose. That's why its size is less than the size of anion is greater than. Okay, I hope you understand. If you understand, like and subscribe.